You're listening to On the Ear, an audiology podcast sponsored by SpeechTherapyPD.com. I'm your host, Dr. Dakota Sharp, AUD-CCCA, audiologist, clinical professor, and lifelong learner. While I primarily work with pediatric cochlear implants and hearing aids, I am absolutely intrigued by the many areas of audiology and communication in general. This podcast aims to explore the science of hearing, balance, and communication with a variety of experts in hopes of equipping you to better serve your patients, colleagues, and students. So let's go. We are live and on the ear, brought to you by SpeechTherapyPD.com. About 3 years ago, we had an episode with big updates about all things pediatric amplification, with one of the experts making the field better equipped to manage this extremely important population. Well, guess what, y'all? He's back. We've got a lot to dive into, so please help me welcome Dr. Ryan McCreery. He's the Vice President of Research at Boys Town National Research Hospital in Omaha, Nebraska, where he's also a senior scientist and directs the Audibility, Perception, and Cognition Lab. The APC Lab is a group of audiologists and scientists who are doing research to improve the lives of children with hearing loss and their families. Just a few financial disclosures. I received compensation from hosting On the Ear from SpeechTherapyPD.com, and Dr. McCreery received compensation for his contributions to this presentation. Well, Ryan, it's been 3 years. I couldn't believe that. I went back to see when the last episode was. I was like, oh my gosh, that's like a crazy thought. But I'm so glad
Yeah, it doesn't
back.
feel like it's possible that it was 3 years ago, but if you say so, I believe it. So thanks
It
for
really
having me
was.
back. I've become a regular listener since then, and really enjoyed the podcast. So when you asked if I would be willing to come back, I said for sure.
Yeah, I'm so glad that you agreed. A lot of things have changed since then. I know the research landscape has changed now that COVID restrictions aren't nearly the same as they were back in 2021. I know your role, I think when you came on last time, I think you maybe had just accepted that, much more responsibility as the vice president of research at Boys Town. So I'm hoping now you're all settled in. You've got some cool updates there for us too. But I really was when I was kicking things back up, I asked the audience, what would be topics you're interested in? And I had multiple people who were like pediatric amplification updates. Like, what has been new in this world? What do we need to be doing? What do best practices look like in 2024? And that's what I'm hoping we can get into today.
That sounds great. That's obviously something I'm very passionate about, and I'd much rather talk about that than my administrative responsibilities. So let's go
Of
for
which
it.
I'm sure there are a lot. So last time you were on, we spent a lot of time talking about audibility, and audibility is still kind of the name of the game in pediatric amplification. Any big updates that you can think of? Or I know you talked about you kind of getting things started with Fast Track last time. Like, what kind of projects have been evolving since the last time we spoke?
Yeah, I mean, if it was 3 years ago, and I'm going to have to believe you because I certainly don't remember, but we were kind of just starting a few projects that are now sort of fully mature. So one of the projects that you mentioned is the Fast Track project, which stands for Finding Appropriate Solutions to Treat Reduced Audibility in Kids. And that is in multi-institution collaboration with colleagues at the University of North Carolina, Chapel Hill, Boston Children's Hospital, Arkansas Children's Hospital, the University of Iowa, and Washington University in St. Louis. And at the time that we talked last, we were in the laboratory phase of that project. So we were doing some work in the lab with kids with mild bilateral hearing loss. Mm-hmm. In one phase of the project, we were looking at audiometry that measured the noise levels in their ear canal during testing so that we could see if a child is generating noise during a hearing test, and also then calibrating the audiometer to the ear canal. And we completed the laboratory phase in 2022. And then for the last 2 years, we have been recruiting participants at those partner clinical sites. Okay. where real pediatric audiologists are collecting data with real patients with mild bilateral hearing loss. And mm-hmm. the results are kind of frozen in time right now because we did what's called a registered report for that, which is where before we collected any data, we sealed the methods and the statistical analysis. And now once the data is fully collected, we'll run the analysis that we said we were going to run 2 years ago. And what that ensures is that we said what we were going to do before we started collecting data. So the statistical analysis is locked in. It doesn't change based on the results. And so it's sort of a higher level of trust in a research project because you essentially registered what you said you were going to do. And now an editor at a journal will check and make sure we did that. And if we did, then they'll accept that for publication. And I'm excited to say that we're 4 kids away from being
Ooh,
completely done with that project. So I'm hoping that in the next few months, your listeners will get to read about the work that we're doing at the clinical sites in Fast Track. And then we hope to make the software and hardware that we developed for Fast Track available to audiologists.
awesome.
So it's exciting because if you can calibrate the hearing test to the ear canal,
Hmm.
it takes a lot of the guesswork out of the child's degree of hearing loss. Because, like we talked about before, kids with really small ear canals, the
Hmm.
sound level in the ear canal is higher during the hearing test. And so it looks like their thresholds are better. But if you calibrate to the ear canal like we do with otoacoustic emissions, then
Hmm.
it sort of resolves that issue. And the laboratory data that we already analyzed and are currently working up for publication suggests that that's an important thing for us to do. And so I think the next phase of the project, honestly, is to try to do this with auditory brainstem response testing, because infants have the smallest ear canals of
Yeah.
everybody that we work with. And so the effects that you would see in an infant measuring ABR with an insert are going to be enormous. And so that's sort of something that we would really like to explore moving forward with that, so we can get the most accurate hearing test and give audiologists confidence about the test results that they're getting, that they're not changing over time or fluctuating because the ear canal is changing.
That's awesome. So it's sort of in the most layman's terms, it's like a relay to coupler difference, like an RECD for your audiometry testing, right? That's a fair way to put it.
Yeah, and you could apply the RECD right now to any results that you get in DBHL. And that's going to give you a more accurate estimate of what that child's thresholds are,
Got it.
because that's saying this is what the instrument was calibrated in the coupler. And if you just add the RECD to that, then that will tell you what that child's actual HL threshold is after you take into account their ear canal acoustics. But that's math, and we
Hmm.
don't want people to have to do math during a hearing test. And so
Fair.
it would be really great if the audiometer just measured that and then calibrated to the ear canal, which, as I mentioned, our otoacoustic emissions already do that. So we have
Yeah,
a way to do it.
sure. That's great. That's exciting. So we don't have anything there yet, but that is I'm very excited to hear how that sounds like it's going to kind of radically change what audiometric testing looks like for the better, right? In terms of just better accuracy and catching those kids who are so borderline and with those mild hearing losses who might be testing in the normal range, but in reality have mild hearing loss.
Yeah, and that's the reason why you'll sometimes see kids who don't have otoacoustic emissions,
Mm,
because that's the only test that we do that's calibrated to the ear canal right now. And then we go and do an ABR, or we go and do a hearing test, and their thresholds look like they're in the normal range, or they're sort of in the borderline normal range. And we're like,
sure.
I don't know what to do. But then that kid comes back a couple of years later when their ear canal is bigger. They still don't have otoacoustic emissions, and their thresholds look worse. And the question is, did that kid have hearing loss all along and we just didn't know it,
Mm,
because the only test that was pointing in that direction was the only one that we calibrate to the ear canal? And that's always a hard thing to say, but I think this will give us more accurate tests. And the other thing that we've learned in the last couple of years is it's not just important for the kids with mild hearing loss, which was the focus a couple of years ago, but my colleague Catherine Wiseman has been looking at children who are borderline cochlear implant candidates. So
hmm.
the same ear canal acoustics issues that contribute to uncertainty about mild hearing loss are also contributing to uncertainty about cochlear implant candidacy. So, as you know,
Yeah,
because this is your area of expertise, we base a lot of our cochlear implant candidacy in children on the audiogram.
yeah.
And as you can imagine, the same ear canal acoustics issues that make the mild kids look like they have normal hearing make the kids with severe to profound hearing loss sometimes look like they're in the moderate severe range, or kind of in that borderline range. And so we're currently working on ways that we can apply the same techniques to kids kind of on the upper end of audibility, to see
Sure.
when we might be able to move them into cochlear implant candidacy faster. Because I'm sure you've seen kids who
Oh
don't
yeah.
meet the criteria audiometrically, and then over time they eventually do. And it's like, did their hearing get a little bit worse, or did their ear canal just get a little bit bigger? And these
Yeah.
methods will allow us to sort of answer that question.
Yeah, I'm very excited about that. That is really important work. I really appreciate you guys working on that. And I totally can see the value in that, especially in how much those measures have changed how we approach hearing aid programming. I mean, the fact that what we understand a threshold to be for a tinier ear canal is probably going to fundamentally be different in the next 2 years, is crazy. It's awesome. Okay, so I know, so those are projects that are up and coming. We don't have anything published yet in the fast track data. And also, I'm sorry about my voice. I was at the JMU UNC game. I work at UNC now, but I'm a JMU alum. Double Duke, got
Yeah,
my AUD there as well, and I was there for the blowout victory of a lifetime. So my voice is
that was
still
an
gone.
that was an incredible game. I saw the score and I thought maybe the basketball teams were playing or
Yeah.
something. But that was quite a win for the Dukes.
Yeah.
Congratulations.
I appreciate that. Sorry, but yes, that's why I keep clearing my voice is missing. So I've learned never do football games prior to podcast recordings, but all that being said, with that research kind of down the pipeline, something I know that you and your team have been publishing is in the space of admittance and audibility. I'm trying to remember it just, oh yes, using like the RECD and like wideband tympanometry. Would you mind kind of breaking that down a little bit more?
Yeah, so this is one of the benefits of working at a place like Boys Town is that I am not the only person doing pediatric hearing research. In fact, there's a whole group of us working together. And I have a really smart colleague named Gabby Merchant. And Gabby is one of those unicorn people who did a PhD in the Harvard MIT program at the Eaton Peabody Laboratories and then decided to go get an AUD. So
Whoa.
she's like a legitimate engineer, genius. And then she's like, I'm going to get an AUD so I can solve clinical problems as well. And we were lucky enough to have Gabby come and do her 4th year AUD with us. And we were like, we like you so much. We're going to hire you in our program as a scientist.
I'm not surprised at all.
Yeah. And Gabby does really interesting work on diagnosing middle ear dysfunction in kids, but more specifically, like, how do you quantify whether fluid in the ear is actually causing hearing loss or
Hmm.
if it's just sort of a passing effusion, for example? Well, one day Gabby and I were having a conversation about the difficulty in measuring the real ear to coupler difference. So, statistically, if you look at data from our projects, if you look at the folks at Western in Ontario they invented the RECD and they're probably the best in the world at getting this data, we're still only able to measure the RECD in kids under 3 about 60% of the time. So
Hmm.
that's not great. That means
Yeah,
40% of the time we're using an average that is plus or minus 10 dB, which that is not the kind of accuracy that pediatric audiologists strive for.
absolutely.
So Gabby is showing these data from her lab where they're measuring emittance, wideband acoustic emittance on 100% of the 2-year-olds that are coming into their lab. And I started thinking and talking with Gabby and said, how are you doing this? It would be really great if we had that kind of level of success measuring the real ear to coupler difference. And we started talking, and it occurred to us that when you're measuring wideband acoustic emittance, you're actually kind of measuring the whole thing that you measure when you measure RECD. And so we collected a bunch of data on over 1,000 ears of children where we had the measured real ear to coupler difference,
Hmm.
and we had either tympanometry or their wideband acoustic emittance. And with the help of a statistician, we developed this model where we said, if you have the wideband acoustic emittance, can you make a better prediction than the average RECD?
Hmm.
So the average RECD was within 3 dB of the measured RECD more than half the time, which is really good.
That's great.
So we had measured RECDs and wideband for this big group of 1,000 kids. And because we basically have to measure an RECD and emittance on anybody that comes into the study. And what we did is we built a model that allowed us to say, if we have wideband, can we predict the measured RECD in these kids? And the average RECD was a pretty good predictor. It predicted within 3 decibels across the frequency range about 50% of the time, which is great.
Yeah, that's
That
good.
means if you have to use an average RECD, that means more often than not, you're going to be close. But if you use these wideband emittance measures, which are really easy to get, and everybody has a tympanometer, then you can get within 3 dB about 80 to 90% of the time, depending on the frequency. So it's a huge improvement in performance. And we published a couple of papers now, one looking at if you only have 226 hertz, and one looking at if you have the whole frequency range.
Okay.
And a very surprising result to us was that if you have an intact eardrum, so you don't have a tube or a perforation, the 226 hertz tympanogram is just as good as the wideband acoustic emittance at predicting the real ear to coupler difference. So there's not a big advantage there. And we're a little puzzled by that because the RECD is a wideband measurement, and
Hmm.
wideband is a wideband measurement, and 226 by definition is only one frequency. So
Yeah.
it surprised us a little, but we think in ears with normal middle ear function that those frequencies are sort of correlated with each other very well.
Hmm.
And so maybe that's the reason. But what we were able to do then is we're currently testing that model with a whole new set of ears. Before we release it to clinicians, we want to make sure that the model we developed actually works with a new set of data. So,
Hmm.
it's important. We're excited about this, obviously, but you want to make sure that you're not releasing something that was sort of a fluke, even though it was based on a lot of data. And we're hoping in the next few months that we'll be able to release an app that you could run on a website where you could enter the admittance data and it would spit out a prediction of the RECD that's very accurate. So once we get through this validation phase that we're in right now, we're hoping to make that freely available so that if you can't measure the RECD, you
Sure.
can measure the admittance if you already have that, or even just the 226 hertz TIMP. And that would be a way to predict the RECD if you can't measure it. And it would be more accurate than using just the average.
Wow, that is extremely interesting, and it's so accessible too. I mean, other than having to plug in the values, I mean, just about every pediatric audiologist is going to run a TIMP. And as somebody who works with kids, I feel a lot more confident in my ability to get a, 6 second 226 hertz TIMP versus an RECD with a probe mic, an insert, or, it's a lot more involved on a 2-year-old. So I think that what a valuable tool that's going to be for clinicians who otherwise would just have to rely on an average. That's great.
Yeah, we're very excited about it, and we're also working on a separate model for when the child has a tube or a perforation. So it turns out if you have a hole in the eardrum, the model that we developed does not work very well. But we're thinking if we use a different set of parameters to try to predict the RECD, that we will be able to do that for kids with tubes and perfs, which is a big problem right now because there are no average RECDs for
Hmm.
tubes or perforations. And
Yeah.
so that's a question I get from audiologists a lot is what do I do if I can't measure, real ear or in situ with a baby that has a tube? And right now we don't have averages to use, which creates some error in the fitting process. And it's frustrating because audiologists, of course, want to do the best that they can, but right now we don't have a good alternative. So that's another thing that's sort of in the pipeline that we're working through. And we have a lot of data from ears with tubes or perforations, and we're trying to
Hmm.
see if maybe the wideband could be valuable there too.
Wow, yeah, that's also good. That you're right. That's such a hole in our understanding of how to program hearing aids effectively. And I think having even just averages, yeah, that's going to be a lifesaver for clinicians who otherwise are worried that they're either overfitting or underfitting. And what do I do with this airbone gap? That's really exciting. Okay, so we still know this is important, that audibility is really critical. Verifying hearing aids, of course, is best practices. I know one of the things you've really focused on in your work is outcomes, not just like, hey, it's important to do it, but look at what happens when you do it. Have there been any changes in our understanding of why that's, important over the last couple of years?
Yeah, so the other part of Fast Track that I didn't mention is that we're developing a set of outcome measures that could be useful for kids with mild bilateral hearing loss that you could do in sort of any sound booth that had two speakers in it. So most pediatric audiology clinics have at least two speakers in the sound field that they can use because they're doing VRA testing.
Mhm.
And what two speakers enables you to do is it allows you to do some spatialized testing that's very crude, but it allows you to look at benefit in more realistic environments. Because if you think about speech and noise testing, the way we do it in the clinic, if the masking sound and the target talker are both coming out of the same speaker, that's great, but fortunately that doesn't happen in real world listening. Usually those are
Mhm.
two different sources, and so having them separated gives you what's called spatial release from masking, which is just you hear better when things are spatially separated, especially if you have two ears. And so right now we're validating this with kids with mild bilateral hearing loss, both with and without hearing aids, to show that kids with mild hearing loss are getting benefit from their hearing aids in these situations. But the other angle that we're approaching this from right now is looking at this in kids with unilateral hearing loss. So, as you know from your work, kids with unilateral hearing loss can be really challenging,
Mhm.
and it can be hard to know what to do. And so we're looking at this task that we developed for the Fast Track project for kids with mild hearing loss as a way potentially to put a tool in the hands of clinicians that would enable them to do more for kids with unilateral hearing loss as well.
Sure.
Because that's a question that we get a lot, is what do we do with these kids with unilateral hearing loss? They're being identified through newborn hearing screening at
Hmm.
much earlier ages than ever before, but we're not doing anything. In many cases, they're not getting amplification until they're much older. So there's this big gap, and we're
Hmm.
calling that treatment delay in kids with unilateral loss. And we're trying to see, does that treatment delay, because most of the kids with unilateral loss have some residual hearing that we could provide hearing aids to if we could. And there's so much awesome work being done, including at North Carolina, on cochlear implants for kids with single-sided deafness.
Absolutely.
There's only been 4 studies in the last 20 years on kids with aidable unilateral hearing loss. And so we feel like that's a big gap in our understanding. And so we've started some projects where we're moving to get some better outcome measures for these kids with unilateral losses.
Yeah, I think that's great. You're right. I feel like we have more and more information on what to do when children kind of fall into that SSD range. But prior to that, I mean, I don't know what best practices are for someone with a moderate unilateral hearing loss or a moderate to severe, when we're not sure how much crossover is happening from an amplified signal, and is that going to make things worse? And yeah, you're right. There's there's a lack of any kind of guidance there, and I think that's going to be really good work for, guiding clinicians in their day-to-day decision making there.
Yeah, we we have some of the best pediatric audiologists in the world at Boys Town. In our clinic, I know that for a fact. And when I went back and looked at 10 years of data from kids with unilateral loss, you would think that you could predict who was going to get a hearing aid and who wasn't going to get a hearing aid based on
Hmm.
maybe the audiogram. But the audiogram was not a good predictor.
Hmm.
And you would think, well, maybe they've been listening to what we've been talking about with the unaided speech intelligibility index. That wasn't a predictor.
Hmm.
And if you plot it out based on who got a hearing aid and who didn't, it was very random, and it probably depended on the clinician. And again, that's not saying that my audiologists aren't doing an amazing job. There may be a lot of other factors that we're not capturing in our retrospective analysis, but the point
Sure.
is we need to provide better guidance on the front end about when kids with unilateral loss might benefit from a hearing aid. When do we need to send them over to the cochlear implant team
Hmm.
for evaluation? There's just a number of different considerations, and you mentioned crossover from the poor ear amplified signal to the good ear. These are all
Hmm.
things that we're thinking about right now as we're trying to help clarify that.
Awesome. So speaking of that guidance, I know one of the things that you are one of the best, one of my favorites at is your talks and presentations. So I know you're out there a lot taking this information, disseminating it in person and through virtual talks. Back in 2021, more virtual, but nowadays a lot more in-person talks. So what's some of the feedback you're getting from clinicians out there with all this new information we have on how we approach pediatric amplification and audibility as a measure and part of that? And what's been some of the things you've been hearing?
Well, so first of all, thank you for saying that. I really appreciate it, and I really strive to make the information that we provide and the research that we do very clinically applicable. I was myself an audiologist for 10 years before I went back to get my PhD, and
Hmm.
so I really have always wanted to make sure that the work we're doing is applicable. And I think we get lots of good feedback from audiologists, and not all of it is as positive as the feedback that you just gave me. A
I
lot of
don't
those
believe it.
questions, or people raising their hand at seminars and asking difficult questions, we take that and we go back to the lab, and we have a couple of projects going on right now that were started because an audiologist raised their hand and said, for example, why does the speech intelligibility index, why is it lower for loud speech than it is for average speech? Because it looks like the line on the verifit is higher for loud speech. Why is that number smaller? Well, we know that's because of the level distortion factor in the speech intelligibility index, but that's never been validated with kids. So we started a
Interesting.
whole new line of research simply based on a question from a clinician. So we get lots of great feedback. Some of it's positive, some of it's just awesome. And we take it back to the lab and try to think about how to answer it, because all of these questions are coming from the people who are actually working with patients. And I don't work with patients anymore outside of my laboratory, which is a really different sort of experience than clinicians who are doing this every day. So if a clinician tells us something doesn't make sense, that's extremely important. It might hurt my ego a little bit in the short term, but it's fun to just take that back to the team and say, what can we do to answer this question?
Sure. Wow. I love that you'll take that feedback and immediately start to try to answer those questions instead of being offended at someone asking a question. That's great.
Well,
What
you
about,
wouldn't believe how often we try things that don't work. I think that's
hmm,
the big secret about research is it seems like, oh, we know what we're doing. We have no idea what we're doing. That's why it's science, and that's why it's really interesting and exciting every day, because you go and you try things and sometimes they fail spectacularly. And it would be fun at some point to give a talk at a meeting just about all the things that we thought were going to be really good ideas that never panned out. I think that would be much more entertaining than hearing us talk about many of the things that we talk about, is just like all the failures that we've had.
yeah.
I think people would be surprised, and it would probably be a much longer talk than most people would be interested in attending.
Well, I would be first in line to a research blooper reel, and it's just you guys sharing, the things you missed and what you learned from that mistake. I love learning through those kinds of things. Speaking of the research things you guys are working on, I know we're kind of coming up on the end of our time here, but I know that you've had some recent collaborations with people in neuroscience specifically, and I'm imagining that your role at Boys Town has just allowed you to connect with so many other avenues of research that you hadn't considered their connection to audiology even, right? So what's been going on there?
So we're doing some really awesome work right now, and I may have talked about some of the early work that we were doing with Dr. Beth Heinrichs Graham when we talked 3 years ago, because we had been collaborating at that point. And since the last time we talked, there have just been a huge number of publications coming out of Dr. Heinrichs Graham's lab. And my contribution to that is helping her think about how do we measure auditory experience in kids, and then relating that measure of auditory experience to what she's seeing in neuroimaging. So that could be things like the thickness of the cortex, or it could be things like how the brain responds during a working memory task. And I'm so fortunate to work with all of these brilliant neuroscientists. I mean, as an audiologist, I don't claim to be a neuroscientist, but I'm lucky enough to have my name on a few neuroscience papers because they had some really interesting questions about kids with hearing loss that I think are really reinforcing a lot of the things that we're seeing in our work behaviorally. So a lot of the work that we do, we're asking about things like hearing aid use or audibility, or putting those two things together and looking at as a measure of auditory dosage. So it's gratifying to see those measures that are very practical and things that clinical audiologists do every day,
Hmm.
to see that getting incorporated into this cutting edge neuroscience, where those are the things that are predicting how well the kids' brains respond during a working memory task or during a
Hmm.
language task. Like, that's really, really exciting. And we're starting to see some relationships between what we're seeing in the scanner and like classroom behavior in kids. So
Hmm.
there's some really cool things I think coming down the pike in terms of that collaboration, and it's only getting stronger and stronger as we start to uncover these things. But that's why when you're a researcher, it's so important not to get stuck in a silo and just be like, well, I'm a pediatric audiologist. Talking to colleagues in neuroscience, in language, which is another big
Hmm.
center that we have at Boys Town, um, these things are all related. And so it's just great to be in a place where everyone's sort of focused on very clinical research. And it sparks these kinds of opportunities that I don't know that I would have if I were at a university or at some other research institute where things are a bit more siloed.
Sure. I'm really excited to read about more of what's coming with that because yeah, that's one of the biggest things too is sure we're learning more and more and we're getting better and better at, providing intervention for these things, but it only seems like we uncover more about the far-reaching aspects of hearing loss in kids as you guys are able to collaborate more with people outside of our, purely hearing testing, fitting, hearing if it, all these diagnostic kind of principles. We want to dive more into what's happening in school, what's happening language wise, fatigue. Now we're learning more about fatigue and effort and brain power, right? And that's just only going to help these kids be more successful. I think that's really exciting.
I totally agree. And we recently installed what's called an optically pumped magnetometer, which
Whoa.
is like an EEG on steroids. So it uses these interfaces that attach to a helmet that we 3D print for an infant's head. So one of the issues with
Whoa.
MRI and magnetoencephalography, which are two of the other types of neuroimaging that we do with babies, is that you can't throw babies in the MRI and tell them to hold still. They won't. And the Meg has a helmet that comes down over their head, but it's based on sort of an adult sized head. And so if they're moving their head around, you can't get a very good image of what's happening in their brain without the movement. But the OPM actually, we print these helmets and put them on, and it's a cutting edge technology, but we're really excited because infancy is where a lot of the action's happening. Like before we can measure speech recognition, we want to know what's happening in the brain. And up until now, EEG has allowed us to do that to some extent, but we really want to have better spatial resolution of the brain while we're doing this. And so this new technology is going to allow us to move from school age kids, which is what we're currently focusing on in our neuroimaging research, down into infant populations, which will be really exciting.
Cool. Yeah, I mean that's one of the toughest things, right? Is the just from where I'm working with, pediatric cochlear implants, we need children to have imaging prior to, and the fact that they'll have to go through sedation and everything that we need for that kind of thing. Those kinds of opportunities are really exciting, and I just love to hear, 3D printing has come so far. It's so cool that we're finding ways to blend that more into what we're doing in like audiologic research. I think that's exciting.
Very exciting. Yeah, it's a whole different world than it was just even a few years ago. So
Awesome. Well, I just want to say, as we're kind of out of time here, I really appreciate the APC Labs Instagram. I think the last time I saw you, I was really excited and very complimentary and grateful for the infographics, the things that we put up around in our clinic that kind of talked about audibility and the importance of good access with hearing aids. And now I feel like you all have just made a quick turn into social media, disseminating that information in such a way that like I am learning so much from and happy to share and get that to more students and families. So thanks again for the work and how dedicated y'all are to that aspect of research. I think it's really admirable that you guys just really emphasize dissemination in a way that I think is awesome.
well, I say this every time someone gives us props for our Instagram, which is that I have nothing to do with that other than I have ideas. But I'm probably one of the least creative people that you'll ever meet in your life in terms of like being artistic. But I've been so lucky in my lab to have people like Mary Spratford, Maggie Smith, and now Zoe Jensen Pickett and Jaden Tryon. They're all amazing people who are so creative and come up with these ideas for how to convey the information. And Maggie Smith is now finishing her degree in speech language pathology, and she's going to be a speech pathologist in like 6 months.
Oh,
So,
that's awesome.
it's just great to have these people coming through the lab that are so committed to communicating the science to broader audiences. And we're getting a lot of really positive feedback. And also, again, I'm just so lucky to have the team of people that I work with.
Yeah, that's awesome. Do you happen to know, I'm trying to remember off the top of my head, I think it's at Boys Town APC Lab.
Yep.
Right.
That's the handle on Instagram. And we also have a Facebook page, although I would say that gets a lot less traffic.
It's kind of slowing down these days. Instagram's still going strong. Awesome. Well, thanks so much for joining me, Ryan. I really appreciate it. It's been so great to have you back on. Thanks again for taking the time, and I hope to talk to you again soon.
No problem. The SWAT team just came by my house, so they were like, there was a lot of activity right here, so I apologize for that. But
no problem. Here, I'll say our goodbye one more time.
Okay.
Well, I'm hoping everybody will give you a follow. Thanks again so much, Ryan, for joining me. It's been great to have you again. I'm excited for the research that's coming out. Just keep doing what you're doing. You're just making our lives as audiologists a lot easier.
Well, thank you. I really appreciate the opportunity. And as always, Dakota, it was wonderful to talk to you. And I'll be looking forward to your future episodes. I was really excited that you're recording again. So thanks for what you do.
And that's all for today. Thank you so much for listening, subscribing, and rating. This podcast is part of an audio course offered for continuing education through Speech Therapy PD. Check out the website if you'd like to learn more about the CEU opportunities available for this episode, as well as archived episodes. Just head to speechtherapypd.com/ear. That's speechtherapypd.com/EAR.